and welcome to another episode of MedSynapse podcast series, where we bring you the latest insights from the forefront of medicine and healthcare innovations. I'm your host, Hetvisha, and today we are diving into a transformative topic, just transforming diagnostics, the role of AI in enhancing accuracy and efficiency in medical imaging. And to help us decode this fascinating subject, I'm thrilled to welcome a trailblazer in the field of radiology, Dr. Praveen Shastry. Dr. Praveen is a distinguished radiologist and healthcare leader with an impressive academic and professional background. From holding advanced degrees to his roles as head of technical and clinical academics at Manipal Health Math and the director of Orange Diagnostics. Doctor's expertise spans both clinical and operational excellence. So, welcome, Doctor, and thank you for joining us today.
Thank you very much for having me over, ma'am, and thanks again for the kind introduction. Thank you.
Thank you. Doctor, before we dive into the main topic, can you just give a brief overview of your entire professional journey and what interested you in AI?
Sure, ma'am. So I am basically a radiologist who's keen on, I'm a musculoskeletal radiologist doing a bit of administrative roles as well. So with that, I run my own entrepreneurial venture and I run my own chain of diagnostics. With all of this, there was one thing, if there is something that can actually help me increase the efficiency and cut down the time required to give quality and precise reports to my patients, that is something that I would embrace with. And like looking at it in a holistic approach, not every case that a doctor sees is new. It is actually an nth repetition of the same set of pathologies. So wherever there is pattern, that there is a role for AI to conquer. So this is something that intrigued us. And thereafter, we've gone and built a lot of tools that have actually resulted and made an impact in the field.
That is quite interesting, Doctor. And thank you so much for sharing your entire journey with us. Now, let's start with the main question and a big picture question, actually. So, how has AI integration changed your daily diagnostic workflow, and what specific improvements have you observed in terms of time efficiency and diagnostic accuracy?
Very good question, ma'am. So before getting into the answer proper, I'd like to walk you through how a day is in the field of a radiologist. So whenever somebody comes with a problem and that needs a diagnosis, so a patient is subjected to CT or MR, right? So once the scan is done, these scans are procured. There's a specific format in which it has to be procured. Let's say if there is a liver lesion, there is some pathology expected in the liver. There is a specific protocol that needs to be followed. Only then, like the images have to be procured in a specific pattern. That is where the journey starts. And once it's procured, then it needs to be read by the radiologist and a specific report is given to the patient. Now, this is when we are dealing on a very small scale. Now, when this happens at a larger scale, let's say we're dealing with 100 centers and more than like 5,000-6,000 patients are being imaged every single day, there is a lot of chaos, right? So that is where AI gets into the picture and solves a lot of problems. Now, there's another layer of challenge in the entire process, that people procuring images are not very well trained in India. We don't get best of the best technicians to say. So these are trained individuals, not aptly qualified. So there are multiple layers of challenges because of the population being the crux. So where all AI has been extremely helpful is in homogenizing the image acquisition process. AI has chipped in and we've been able to standardize and homogenize across 100 centers pan India. We've been able to deploy very specific internationally accepted set of protocols. So this actually adds a significant value to image acquisition process. This is one. Next, once the images are procured, post-processing, whatever process is done, then it hits a raw server. Now, again, not all radiologists are comfortable in reporting cases from head to toe. So each RAD subspecializes. So we have a set of doctors who are neuroradiologists who look into the brain only. And then we have musculoskeletal radiologists who look into like joints. So it makes no sense for a brain case to land up with an onco-radiologist or a musculoskeletal. That is where routing makes a huge impact. So we've built a routing system wherein each and every case ends up with the best possible radiologist on the platform. This again is where AI has made a significant impact. And then next step, when a case is assigned to a radiologist and then he gets to solve the case. Now it's a Pandora's box. Nobody knows what's in it until it's opened. And once we've opened it, and then there are a few instances wherein the docs get stuck. It could be condition A or condition B. And that is again when large language models, AI models, will help us make decisions. It will help us find tune down our decision. And at the end, after the decision is made, we'll have to generate a structured report to communicate with the referring doctor, right? So to generate the report, which hitherto took around half an hour or 20 minutes, this record, whatever report has been generated, has to be legally correct. It has to be very coherent to the referring doctor. So all of this, which hitherto took around 15-20 minutes, can be done in less than like 30-40 seconds now, all thanks to AI. So AI is useful right from acquisition to delivering the report at every single step. So very confidently, I can put it saying that it will save a few hours every single day if done right.
Yes, it actually sounds like AI is not just a tool but also a partner in diagnostics also.
Very, very true.
So if you could just share an example case like, where AI significantly impacted the outcome of the entire patient case.
So there are n number of results like these. So I'd love to something that's coming off my over the right now I can think of is Indian radiologists. Like, just to give you a perspective again, in the US the number of radiologists are 1 per 1,000 population, but here it is 1 per 1 lakh. So we are significantly understaffed. So given that, an average radiologist is expected to read significantly higher number of cases every single day. And in this busy routine, there's fatigability. They'll have to apply their mind to every single case. And there is a probability that very critical findings like pneumothorax, that is air inside the lung, or let's say there's a case of trauma. If there are submillimetric bleeds, and that to at specific areas, let that be basic frontal, basic temporal, at specific sites which are actually called as second look areas or hidden sites in the brain, and it's very subtle, submillimetric bleeds, there is a probability of that going missed on a routine workload. So that is when AI can chip in and actually highlight such findings and make a huge difference to the patient.
That's really fascinating. Okay. Now, sir, in your experience, how does AI perform in detecting subtle abnormalities across different patient demographics and varying image qualities as well?
Yes, ma'am. This is actually a very good question. So, India is known for that spectrum of everything to say. So, we have very primitive kind of machines which are dual slice CTs to the most advanced state of the art 512 slice or a 256 slice. And again, when it comes to MR, we have a very small magnet to the best out there. So, this spectrum is something that is challenging when it comes to the Indian system. So, and again, there are a lot of, this is one good point that I'd love to highlight here is, there are a lot of Western solutions on AI. When those solutions are tested in Indian waters, they underperform. Why so? Because this being the thing, which are stellar in the Western world are subnormal, like suboptimal performance they give in the Indian setting. This is again something that we have learned over the course in the last one or 2 years. So coming to the spectrum of solutions out there, so we have something like I can just go on talking about each and every system. So chest X-ray, a lot of AI work is being done. So finding infection, pneumonia. 2, if there is a history of trauma, if the patient has had a fall, to finding those subtle rib fractures. There are a lot of, so chest is something which has heart, which has lungs, which has bones, which has soft tissue. So there are a lot of structures in one single image. So it needs a lot of specific eye of an eagle to find these subtle things. So chest X-ray is where a lot of work is being done. This is one. Next, when it comes to trauma, again, we have bleed, we have fracture detection models, which have made a significant. These are very fine details which AI can actually flag. And then we have again spine. MR spine is where a lot of images are being taken to look for disc bulges, people with backaches. So that again that's a very repetitive task. You just have to measure the canal diameter. Any task that is patternable and repetitive, AI does a phenomenal job.
So it
So
actually can
I can,
adapt to such diverse scenarios also.
yes, ma'am. So I can go on and on about the available tools out there, but then to sum it up, a lot of subtle things, AI definitely does add value.
It's vast also, I think. Now moving on to the operational aspects, Doctor. So how has AI implementation affected resource allocation in your radiology department, especially particularly in terms of prioritizing urgent cases and managing workload distribution as well?
Yes, very, very, very aptly put. So, because of the load that I earlier mentioned, because of the higher caseload, suppose we begin our day with around 200 cases to read. It's very important to know what demands our attention at the earliest, right? So that is where AI as a triage tool significantly adds on. So important cases, critical cases, if they are flagged. So dealing with those cases will lead to number of lives saved rather than taking it by the order of chronology. Or so triaging is extremely important, and there are n number of tools that help us very efficiently triage. So triaging part is also very important.
Important. I agree. I agree to that. And it also enhances the accuracy also with AI. So now with the increasing adoption of multimodal imaging approaches, so how does AI actually in AI integration help in synthesizing information from different imaging modalities like MRI, CT, and PET to provide more comprehensive diagnostic insights?
Yeah. So I would love to tweak this a little more because we are not doing intermodality integration. Rather, if a patient has to go for a high, like if a person has a problem with CT, he's asked to take up an MRI. So that correlation is generally done by the doctor. But integration of different AI for the same patient is something that's more interesting. Two modalities of AI integrated on the same patient would give exceptional result. Meaning to say, we have computer vision models. All that we spoke about until now are all computer vision. You upload a stack of images, it will give a probable diagnosis. That coupled with a large language model, something like a RAG fine-tuned model, which would generate a standard report. So one tool, an agent, which can actually read, understand, generate a comprehensive report. This entire integration of different AIs for the same patient would actually make a huge difference and eventually lead to faster and more precise report.
Actually, that's really remarkable. And I can think of that AI actually acts like a bridge between it actually bridges the gap between different modalities and actually it also highlights its potential also. So now, Doctor, many radiology departments face resistance to AI adoption from experienced practitioners. So how did you address concerns about AI potentially replacing clinical judgment, and what strategies work best for gaining buy-in from senior staff members as well?
Yes, ma'am. That's a real world problem that you've brought up. So definitely there is resistance. There like now I'd like to take a step back and approach this more holistically. So AI when it comes to healthcare, we just have a few low-hanging fruits. Wherever there is structured data, for every stack of images, if there is a ground truth or the report, that is a point of entry for AI into healthcare. And that is precisely why radiology is the point of entry. Because for every set of images, there is a report. Likewise, for now, there is dermatology, there's a lot of AI going on. Next is ophthalmology. Because people can see, document it, and then give a report. So you have ground truth and very structured data. And finally, emergency medicine and critical care. wherein it's all about numbers. You have a set of monitors, it's numbers, so serial trends. So these are the areas wherein wherever there is structured data and a ground truth. So that is where AI can make a difference. This having been said, there are two big challenges in implementing AI. One is the operational challenge. Whatever packs or the plays that we are working on might not be AI. It might not be easy to integrate AI on that. This was one of the key challenges initially. So integrating AI into workflow. Thereafter, do we get to see its efficacy? But the first door by itself had a lot of problems. So we had to do a lot of circling around and to find the like halfway around. So this after that mindset, people challenges and the technical challenges. So after having addressed all the technical challenges, it was the people challenges. So again, I would like to stratify it into two different ways. One, they would find it as a threat. They would actually so that is one. Second, this is a huge ethical component. For that part being threat, we'll have to make sure that it is here to enhance our abilities and not eclipse it. This was the point that we had to make and convince them. Second thing was, most of the solutions are not 100% accurate. This is a challenge unanswered even now. So whenever a solution is wrong, and that leads to a loss of life or morbidity, who has to take the blame? Is it the developer? Is it the company that helped the developer? Is it the hospital that deployed it? Or is it the patient who chose AI over a radiologist? These are concerns that have to be like taken up. These are very relevant ethical questions out there.
Right.
So at every step, but to make everyone give it a try, the solutions have to be highly accurate and using them have to be seamless. That has really been kept a lot of senior doctors also open into it.
That is really interesting to know, doctor. So what would be one advice that you would like to give to the doctors who are actually trying to adapt or take one step to adapt AI?
So I would really urge them to go with the open mind, try whatever solutions are out there, and more than just being an end user or just a subject matter expert, I would ask them to understand how it works and start contributing to it. Because it is our problem. We can't expect a person from a tech background to solve it. So we'll have to lead the problem solving from our end. It would be really nice if doctors are the ones leading healthcare industry AI building. So that would be my call.
That's actually so beautifully said by you, doctor. So now let's talk about certain limitations that AI possesses. So based on your research and clinical experience, what are the current limitations in AI's diagnostic capabilities that need to be addressed? And how do you envision these being overcome also through advances in deep learning architectures?
Sure, ma'am. Now that you brought deep learning into it, I'd just like to go through the entire spectrum. Earlier, the AI work all began with convolutional neural networks, right? That is around 8-10 years ago. So a lot of work has been done in convolutional neural networks. Now, these were pre-trained with non-medical images, very sharp non-medical images. So the accuracy was somewhere between 80 to 90, most of the solutions. After that came vision transformers. So vision transformers, the accuracy improved significantly, but these are data hungry, very, very data hungry kind of models. Even with vision transformers and CNNs, we haven't been able to cross that 90-95 mark very easily. And now we have a new thing. And again, with convolutional neural networks and vision transformers, there is no point or no concept of integrating history of the patient, which made a huge difference. It was all computer vision only. Now we are in the age of VLMs, vision language models, wherein you can actually integrate the entire case history also. We can actually add tokenization is what we call. With every stack of images, we can add tokenization. And that actually, suppose there is one haziness. I tell you that the haziness is there since a long time, it could be tuberculosis. That being there since a very short time could be just a consolidation of acute etiology. So knowing history, the clinical data, this was a huge challenge earlier. which is now being addressed. So you can add uh, all the relevant clinical history. This was one thing. And ethical concerns, of course, are challenges that need to be addressed in days to come.
Yes, I think these limitations again with time can also be overcome well, and I think it's a journey from the beginning till the end. That how will everything happen? And I think we've also come a long way, and there's a long way ahead as well. I suppose. So now,
True.
Doctor, finally, here's a question that's often on everyone's mind. Can AI actually replace doctors? And if not, why?
Lovely, ma'am. I'd like to just take the liberty of sharing a story here. Just like how we have Tesla self-driven cars. To build a self-driven car is more challenging. We also had the concept of this. There's a story out there which is very relevant to this context. So we also had self-driven aircrafts. So making a self-driven aircraft is way easier than making a self-driven car which can actually handle a set of hurdles, right? So let's say the prototype was ready on the D-Day, and then the team that built it were asked if they would prefer, they for themselves and their families would prefer a manned aircraft versus the one that they built. All of them, I repeat, all of them preferred a manned aircraft over a unmanned aircraft. So this is the way story goes. And healthcare is no different. It's a matter of life or death. So there's a lot of things that AI can never replace. So AI can suggest treatment, but to cure is for the doctor. That is the way forward. And there's a lot of things that the gut, the feeling, the experience that a person brings in. So whenever there is something that has to be dealt with great sensitivity, breaking the news of something like a cancer, I don't think AI is out there yet. So AI can never replace a doctor or a radiologist, but somebody who's really well versed with AI can. So
Yeah.
that would be my take on it.
So it is more like it is making doctors' lives a little easier also. And I think there's something called as human touch that remains very indispensable with AI, especially in medicine field.
Very true, ma'am. Totally agree.
So now, Doctor, this as we wrap today's session, this has been such an enlightening discussion, and thank you for sharing your insights and experience in AI's role in diagnostics also, because this is something a topic that is very undiscovered and untold, but with your guidance, it was really interesting, Doctor. So thank you so much.
Thank you for having me over here, ma'am. Thank you so much.
And to our listeners, thank you for tuning into this episode of MedSynapse podcast. And remember, if you're a healthcare professional who's eager to delve deeper into medical topics or have questions, do not hesitate to join us on the MedSynapse platform. MedSynapse platform is not just a resource, it's a dynamic space where you can connect with your medical peers, participate in meaningful discussions, and contribute to the ongoing evolution of healthcare. So until next time, take care and stay curious and keep learning.